Hi, everybody. This is the final piece of the course. And there's no new material here. It's just an overview of the course and helping you prepare for the final. And so basically for the final exam, there's going to be two types of problems. One type of problem is where you have to look at some sort of research and one, identify the levels of measurements for each variable. And then two, state what the appropriate statistic is to look at the relationships between those two variables in the study. And then the second type of problem is looking at SPSS output and making the correct interpretation of the output. And then to be able to write those interpretations in a formal paragraph, results paragraph, like we've been doing for the whole semester, essentially. And so I'm going to post this Word document. So it says practice problems for the final exam, but it will also review what you need to go over to prepare for the final. And so if we look at this top part, it says review. And it says homework 2, levels of a measurement. So way back when, levels of measurement, homework 2. So here I'm at the top of our module of our class in Canvas. So the syllabus is the first module. And you go down and chapter 1, homework 2, levels of measurement. So go ahead and review this. And I'm going to go over this homework in a second. So if you can't remember, levels of measurement is that stuff that is nominal, ordinal, interval, and ratio. And so a quick review is nominal is stuff that's categorical. So they're categories such as major or let's say religion. So for example, major in college, you can't have something that's more or less of a major. It's just different types of majors. The same thing for religion. You can't say something's more of a religion than another thing. They're just different categories. And so, although you might have numbers, so you might have 1 as psychology, 2 as sociology, 3 as English, as majors, you might have numbers. Those numbers are not real numbers. They're just a way to indicate the categories. So you can't multiply, subtract, etc. You can't do mathematical operations with those things. So again, nominal is categories. Ordinal is there's more or less of the variable, but they're not equal intervals. So if you have an ordinal scale, they're often like ranks. And so I think the example I gave in class was if you have me rank American food, Thai food, and Indonesian food. Thai food and Indonesian food, I might put, I have to think about this. I probably would put Indonesian first, let's say, Thai second, and American third. However, Thai and Indonesian are very close to each other, as you might be able to tell because I actually paused there because I couldn't tell which to put first. And then American food is considerably lower than those other two. So even though there's a rank, 1, 2, 3, there's not equal intervals because the difference between Thai food and Indonesian food in terms of my liking of them is very small, whereas the difference between Thai food and American food is quite large. So ordinal, again, is there's more or less of the variable you're measuring. In that case, you're measuring how much I like those different types of food. But there's not equal intervals. So the differences between 1 and 2 and 2 and 3 could be different. Then we get to interval. And then interval is there's more or less of the variable. However, there's equal intervals. So for example, temperature is a classic case measured in Fahrenheit, because 0 degrees Fahrenheit does not mean there's no temperature. So there's no true zero on a Fahrenheit scale, but it's interval because the difference between 30 degrees and 40 degrees is the same as the difference between 90 degrees and 100 degrees. It's 10 degrees difference on that Fahrenheit scale. So they're equal intervals. And there's more or less, it's either hotter or colder, but there's no true zero. You can't say that 0 degrees Fahrenheit is no temperature. So when we say for the final exam, you can kind of ignore the issue that we had talked about in the assignment. I'm going to go over this in a little bit. If you have what we call Likert scales, so if you say 1 through 5 from agree to disagree, or strongly agree to strongly disagree, we could have arguments all day long, whether that's ordinal or interval, whether the difference between 1, 2, 3, and 4 are the same. So that's more of a philosophical question. For the statistics, what we say is it approximates interval level scale. So if we have a Likert scale, 1, 2, 3, 4, 5, we aren't going to have the long philosophical debate whether that's ordinal or interval. For our statistics, it's okay to say it approximates interval. And then finally, there's the ratio level of measurement. Ratio has all of the things that the interval level of measurement has. There's more or less, there's equal intervals, but now there's a true zero. So since we talked about temperature, the Kelvin scale of temperature has a true zero. We can also think about speed. So in terms of driving your car, the difference between 20 miles per hour and 30 miles per hour is the same as that between 40 miles per hour and 50 miles per hour. It's 10 miles per hour difference. So it's equal intervals. However, you can be a zero. Your car can not be moving. So there's a true zero. And these are important because these determine what statistics we can use. And so we're going to get into that a little bit later with the practice problems. But what I'm going to do is I'm going to review homework 1 real quickly. If you don't need to review this, you can go ahead and speed up this recording and skip it if you want. But I'm going to review this. And so what I recommend is that if you don't remember your logic behind your answers for this homework, is to redo this. And so if you go back into our module, chapter 1, it's actually asking you to look at this, the spring stats survey. It's in chapter 2. So if you're wondering where this thing is, it's in chapter 2. So chapter 2, spring stats survey, is in chapter 2. I might actually duplicate it into I probably will do that right now because I don't want to forget it. I'm going to actually duplicate it right by the assignment so we don't have any confusions on this. And so let me go into my handy dandy stuff. Yeah, okay. And then here it is right there. And so I put it right here also. And I'm just going to edit that. And so it's right there, right underneath the homework also. It is in chapter 2 still, but I just thought I'd put it there just to make it easier. So I would highly recommend that you look at that. The homework is basically saying, look at this survey and for every question, say what the level of measurement is. So I'm going to go over that real quickly now. Again, if you want to do it on your own first before listening to this, that might be a useful review. Okay, so number 1, eventual cure goals. So somebody's just going to put their career goal, whatever occupation they want to be. So that is nominal. It's just going to be categories. There's not something that's going to be more or less of a career goal. It's just that there's different career goals. So it's nominal. Number 2, I won't read all the questions. You can read them. Number 2, we have from very certain to not uncertain at all. This is one of those things that's a Likert scale. We could argue about whether it's ordinal or interval, but let's just say it's interval because for the final exam, it's just okay to say it approximates interval. That it's more or less, you can be more or less certain. And we're going to say this approximates an interval level scale, that these differences between these bubbles are roughly equal. 3, this is ratio. So it's about money, it's about dollars. You can have $0, so it could be a true 0. And there's an equal interval. And by the way, for the statistics that we're looking at, there's really no difference between interval and ratio. So the statistics that we're studying, it doesn't matter if the variable is interval or ratio in terms of the stats. Those things are treated the same. However, I'm going to ask you to put the levels of measurement, so you, of course, would like points getting it correct, whether it's ratio or interval. Number 4, so we have definitely no, definitely yes, and we have a Likert scale. So this is interval. You're more or less thinking that you're a feminist. And we're going to say this approximates equal intervals. 5, here we have more or less. Protect against terrorism to privacy. So this might not be the most ideal interval level scale, but this is an interval level scale. We're just going to say that there's gradients here about balancing these two things. So this is interval. Number 6. So this asks about the annual income to be in the top 1%. So it's money. So money again is ratio. You can have 0 money. And there's equal intervals in dollars and cents. This asks whether you think that Hillary Clinton should run. This is back, way, way back when. This is a bit of an old survey. So it goes from definitely not to definitely do. So this is, again, more or less. This is more or less on this variable. Do you think she should run? So it's interval. At the very least, approximates interval. So here it says, what are the chances that she'll win? From 0 to 100. No chance, 0 to an absolute for sure chance. This is ratio because you have a true 0 on this variable. So the next one is a percent to chances. That's ratio. Number 10 is similar to the question above. Should Jeb Bush run? From definitely no to definitely yes. And there's gradients here, so this is approximating interval. Then 11 and 12, we have the percentage again. So there could be 0%. So this is ratio. And the percent difference between 10 and 20 is the same as that between 45 and 55. So it's equal intervals, but you have a true 0, so it's ratio. Number 13. This is ratio. You could have 0. And there's equal intervals between 1, 2, 3, 4 boyfriends, girlfriends. 14, I would say that this is ordinal. It's more or less. However, I'm not going to test you on ordinal really during the final exam because we've only done one ordinal thing, which was the Spearman correlation. So I'd say if you get something like this, I would treat it as approximating nominal. So you can have two groups. You could have people that are in a romantic relationship and those that are not. So for our statistical purposes, we could call this nominal, and that we have two independent groups because you're either here, yes, you are in a committed relationship, or you aren't. So again, this is for our statistical purposes. 15, so how old were you? I would say that this is interval. So it's age, those are equal intervals. I'm saying it's not ratio because 0 is not a possible outcome here. So you can't be in a relationship when you don't exist. So approximates interval. Oh, not even approximates, it's interval. 16. Does Claremont colleges have a hookup culture from definitely no to definitely yes? So it's this Likert scale. And we're going to assume that these gradients are approximating interval. Same thing for 17. So does it increase the stress? Yes, it increases the stress. To no, it doesn't. So there's an assumption of equal intervals here, so it approximates the interval level measurement. 18. And so 18 is the employment potential. So how employable are these different majors? From very employable to very not employable in terms of the average employability of a major. So again, we have this Likert scale from low on the variable to high on the variable. And we're just going to say this approximates interval level measurement. That's true for all of these. So you do the same thing for the different majors. 19, major is a category. Psychology is not any more or less of a major than physics, let's say. They're just different types of majors, so it's a category, so it's nominal. 20, so we have people rating themselves from very liberal to very conservative. So it's more or less. So more liberal, less liberal, or more conservative, less conservative. You can sort of say either one. It doesn't really matter. And we have the Likert scale, so we say it approximates interval. 21 is dollars. Again, pretty easy. If we see dollars, we know it's ratio. So 22, the first question, your age. I'd say it's interval because you can't be 0. Height, same thing. I'd say it's interval because you can't be 0 inches tall. Same thing for weight. You can't be 0, so it's interval. But again, for our stats, it doesn't really matter whether it's interval or ratio, but it will matter in terms of getting some points for getting level of measurements right. 23, how many hours of sleep did you get last night? That's ratio. You could have 0 hours. And time, hours, is equal intervals. 24, so how many aspirins did you take in the last week? So that's ratio. You could have had 0 aspirins, and 1 aspirin versus 2 is the same distance as between 5 aspirins and 6. It's the same thing for all of these things. So ibuprofen, acetaminophen, all those things are ratio levels of measurement. Just to reinforce the thing here is that it's about levels of measurements. How about how you measure it? It's not the nature of the thing. And then 25. So how many times have you exercised in the last week? So again, that's ratio. So you could have exercised 0 times. And the difference between 1 and 2 is the same as 3 and 4. So, have you read the New York Times? Yes, no. Sorry about that. There's a plane going right over my apartment. And the LA Times? Yes or no? So, in terms of the philosophical answer, it's or no, because this is more reading. Yes, it's more reading than not. However, for our statistics, it's probably most useful to treat this as nominal. And there's 2 groups here. There's readers and not readers. So again, there's sort of the philosophical answer, but there's also the practical statistical answer that's going to help us in our analyses. So like, let's say that I want to take this variable, whether, let's do the LA Times since it's local, yes or no. So I have two groups. We have readers of the LA Times and we have non-readers. So let's say that I want to compare them in terms of their GPA. So GPA is it's actually ratio. You could have a 0. So GPA is ratio. This I'm going to treat as nominal, and I have two independent groups. So if I have two separate groups and I'm comparing them on a ratio level variable, I would want to run an independent t-test. Let's say I want to compare the people. Let's just look at these two variables. I want to look at the people who read the New York Times or don't, and ask myself, is that related to the people that read the LA Times or don't? So I have a nominal variable here. I have a nominal variable here. So if I want to relate two nominal level variables, I want to do a chi-square. So 27, how many hours? Hours, so in hour studying. So hours is pretty much going to always be ratio because you have 0 hours. And there's equal intervals between those hours. 28, have you taken AP Stats? Yes, no. Calculus, yes, no. So again, philosophically, these are ordinal. But practically, we should treat these as categorical variables, which means they're nominal. And we would treat these as two independent groups. There's the people that took calculus, and there's people who didn't. And 29, have you used these resources? So the career planning, residential life, etc., all of these resources, yes, no. Again, yes, no, philosophically, these things are ordinal because you use more, you use the resource more if you're yes versus no. So there's an order, higher or lower on the variable. However, again, in terms of practical statistics, we probably just want to make these two separate independent groups. There's the user of that resource and there's the non-users of the resource. So we would actually practically treat it as a nominal level variable. And then the last thing is actually what section you're in. So these are different class times. This would be categorical, so it's nominal. There's not more or less. There's not more of a time or more of a section than another. So these things are nominal. So that's a review of those. If you don't understand those, certainly come to one of the live sessions online. And then let's go to the review sheet. I'll close this. So that's that homework. So I already mentioned also that there's going to be questions. So one type of question is what we just sort of prepped for a little bit. You have to identify levels of measurement and you have to do the appropriate statistic, and we'll have some practice problems below. And then we have the lab problems. So review all your labs, all your SPSS labs, starting with lab 3, independent t-test. So review all the labs for all of our inferential statistics, starting with lab 3. So for these problems, you'll need to be able to read the SPSS output. I'm glad I'm doing this. Output. And interpret the findings accurately. And to interpret them accurately, you need to write a formal results paragraph. So what I'll say to do these things is obviously review all the labs. There's videos of the labs. There's also videos reviewing the solutions for every lab. So I didn't grade, just like the homework, I don't grade your labs based on whether you were correct or not. I graded it whether you did the effort to do it. And so what I do when we had class is I would review it in class, but here online I have a review or solutions video for each of the labs. So make sure that you watch each of those labs or videos in terms of solutions. So review the stuff that you've done. And if you haven't done it already, review the solutions or review video of each of those labs and see if you were correct. Also, we have a ton of sample problems in our lectures. So those sample problems in our lectures that then you were tested on in the exams have formal results paragraphs that you were writing. So I would review your old lectures and your notes for the exams because we had formal paragraphs for each inferential statistic. Same thing for the homework problems. So the homework problems, we had results paragraphs that you had to write. So given that we're doing inferential statistics on this final exam, so it would be the homeworks that have to do with the independent t-test, paired t-tests, one-way ANOVAs, repeated measures ANOVAs, the correlations. You can count the linear regression, so simple linear regression, and then also the chi-square. So we're not going back to the z-test. Those z-tests are conceptual bridges to help us understand inferential statistics, but z-tests are not used typically because we don't have the population that's measured. We have a sample. So since we have samples, we do the inferential stats that I just reviewed just now. And so all those homework problems, starting with independent t-test, we've had reviews of that. So the independent t-test and the paired t-test, we reviewed those in class. And then for the other inferential statistics, there's videos reviewing the solutions to the homework. So at least starting with the ANOVA homeworks, there's solution videos or reviews of the homework there. And so watch those videos if you want to double check your results paragraph. So there's lots of sources here to study for this. So again, review your labs, review the videos about the labs, review the solutions or review of the lab solutions, the videos, and check your lectures and check your homeworks to review how to write the formal results paragraphs. And again, if you have any questions on that, come to one of the live sessions. So now we're going to get to the practice problems. So there's no practice problems for the lab stuff because we have all that stuff online. And so look at the videos, review your labs, review the videos for the solutions to the labs. And that's going to be reviewing for those types of problems. For the other type of problem where you're going to be given some research, you have to identify the levels of measurement. This was a good start to review as homework 2, but we also have some practice problems below. So this would be very close to what we're going to have in terms of these types of questions on the final exam. So you're going to be asked to do two things. You're going to be asked to identify each variable and its level of measurement. For the final exam, you don't need to distinguish between the IV, PV, and DV. Those issues are more about research design. They're not really about statistics, because for statistics, as I mentioned here, you can actually flip the DV and IV around to run an appropriate statistic, because the statistics is just testing the relationship between two variables. So it's really about the relationship and choosing the right statistic. It's not whether the DV is labeled properly or not in SPSS. It doesn't matter, actually. So you could actually put what is your IV or PV in the thing that says dependent variable in the SPSS. That's okay, as long as you're doing the appropriate statistic for levels of measurements of your variables. It's just testing the relationship. The relationship is the important thing, not whether your labels are right in terms of the stats. Then the second part of these types of problems is, given the levels of measurement of the variable, state the appropriate statistical analysis for the research. So for this, again, levels of measurement is important because levels of measurement tells us what statistic is appropriate. So let's go ahead and look at these. And what I'm going to do is I'm going to run through each problem. And if you want to try to solve it first, you should solve it, pause the video, and I'm going to give the solution. So the first one's a little bit more complicated because we have actually two things we can look at, because we have the outcome is attraction. So we have an IV. Again, you don't have to label it, but one variable is color. So in this case, red, for example. So does red cause more attraction? So that's one relationship we want to look at. The second relationship is social sexuality. So does social sexuality affect attraction? So there's actually two things here to answer. But first, there's three variables, so let's label the level of measurement of each of the variables. So color, right here. So in this study, the researcher is presenting people in red shirt or blue shirts. And in this case, so that's, let's just start with that first. So red shirt, blue shirt, and actually I'm gonna put something else. Because really you also need to know what the research design is. And that's whether it's between subjects or within. So remember, between subjects is each participant gets just one level of the IV. So if it's an IV we're talking about, do they get just one level of the IV? Well, if they get just one level of the IV, it's between subjects. If they get all levels of the IV, it's within subjects. That is going to determine also, with the level of measurement, what stats we're supposed to do. So when we look at color, it says each participant is going to view the same person in either a red shirt or a blue shirt. This is between subjects. So this is a between subjects design because each person sees either the person in red or the person in blue. This is between subjects. Red or blue, just one level of this IV. And this is nominal. So color is nominal. So color is nominal. How about attraction? Let's do this relationship first, the color and attraction. Okay, so attraction is just 1 through 10. So there's no true zero, so this looks like it's an interval or approximates interval. So color is nominal, red or blue. Color in terms of research design is also between subjects. You see red or blue, you don't see both. And then attraction is 1 through 10, it's interval. So we have a between subjects design, red or blue, 2 levels of a nominal variable, and we're correlating it or we're relating it to interval level measurement, attraction. So 2 levels between subjects, we have 2 separate groups, and we're comparing those 2 separate groups on an interval level scale, attraction. That is going to be an independent t-test. So the appropriate statistic for this relationship is independent t-test. And then we have the relationship between social sexuality and attraction. So we need to figure out how a social sexuality is measured. So social sexuality is a PV. We don't have to actually say that, but it's useful to know because we're not manipulating that. And it's 1 through 100. So this looks like it's an interval level scale. So social sexuality is interval. And I'm going to put this here. So for the research design, it really only matters for the IV. Because for the predictor variables, it's hard to think of it being a research design. It's just a predictor variable is going to be an IV. I'm sorry, the predictor variable is going to be interval level measurement. That interval has I and a V in it. That's what messed me up there. So we don't have to worry about the research design here for sociosexuality because we're not manipulating it. So that's really just for the IV. And so we have interval, sociosexuality. We have attraction is interval also. It's 1 through 10. So we have 2 interval level measurements. And we want to look at the relationship. So that is a correlation. Specifically, that would be a Pearson correlation. It's okay if you also answer a simple linear regression, because a simple linear regression is the same as a Pearson correlation. The Pearson correlation is just a little bit easier to run. So for B, this relationship, we have 2 interval variables. 2 interval variables, we want to see if they're related. It's a correlation, Pearson correlation, or a simple linear regression, because that's the equivalent to a Pearson correlation. So hopefully that's relatively easy. By the way, if you were wanting to look for bonus points for this, if you want to look at all of these variables together, it would be a 2-factor ANOVA. So you have an IV of color, you have a PV of social sexuality, and then you can see whether those 2 factors relate to attraction. So 2-factor ANOVA would be a really great answer, but I'm not expecting you to necessarily identify those things. I'm caring more about the one variable against another, but if you said that, I'd say fantastic, you get bonus points. Okay, let's look at the second practice question. So the question is whether perceptions of threat produce higher endorsements of military action. So right away, we see that the participants are split into 2 groups. So it sounds like there's going to be an IV, the researchers manipulating the participants into 2 groups. And when you hear 2 groups, you should be thinking right away between subjects design, 2 separate groups. So we can read further. So we see one group sees the photos of the Twin Towers after 9/11, and the other, a separate group, reads a newspaper article about the same attacks. So after they see this thing, after the IV, they're asked about their endorsement for military action against ISIL, and this is 1 through 10. So 1 through 10 is interval, and again, there's 2 separate groups here, so it's between subjects. And so when we start talking about separate groups, really it's a nominal level variable. You could actually argue that there's actually an order here. There's an order, obviously, that there's more threat seeing the photos versus the newspaper, but for statistics, practically, we will just say that we're going to treat this as nominal. So we have a nominal level variable. It's an IV, and it's in a between subjects design, 2 separate groups. And we have an interval level variable that we're relating to it. So 2 separate groups, 2 levels of a between subjects IV. We have an interval level measurement variable that we're going to relate it to. This sounds also like an independent t-test, like above. So independent t-test, we have 2 separate independent groups, and we're comparing them on some sort of interval level measurement. So remember what the difference between a t-test and ANOVA is. In the t-test, we have typically it's an IV that has just 2 levels. We're comparing 2 things. It could be a PV too, if you look at different times, measuring things at different times. So your amount of sleep during spring break and your amount of sleep after spring break. So that's one of the things we did in lab. So that's also a paired t-test. But for a t-test, you're comparing two things. In ANOVAs, you're comparing three things or more. So that's the difference between a t-test and ANOVA. Are you comparing two things or three things? Comparing two things, there's two groups here. So it's a t-test, they're two separate groups. Independent t-test because we're looking at them compared to an interval level measurement of the endorsement for military action. So 3, it actually goes on a couple pages here. So here we have whether physiological arousal leads to more attraction. So we have to read this really carefully. So it says for half of the people in the study, they did something kind of boring, low arousal, and then they rated the attraction 1 through 10. I'm going to read the whole thing before we start analyzing the variables. And then they did some sort of distraction task. And then the same people, they were asked to run in place high arousal condition. And then they rated the, I don't know if I have this here. Sorry about this. And then after they ran, they rated 10 photos. Oh, actually, it says it right there. Sorry about this. I'm having a little bit of a post-COVID stress disorder here. So they run high arousal and then 10 photos. And then we read on. We have to read everything. So it says for the other half of the participants, she reversed the order. So for the other half of people, they did the high arousal thing, the running. And then they did the distraction test and they did the low arousal thing, the maze. And then after each of those things, they rated 10 photos of the conditions. So we have, looks like here we have two variables. We have an IV, we have a low arousal versus high arousal. So remember, physiological arousal was one of the variables that was mentioned earlier. So in terms of physiological arousal, we have low arousal and high arousal. High arousal right here. And so we have two levels of physiological arousal. And again, obviously, philosophically, these are ordinal. Does higher arousal is more than low arousal? However, in these situations, remember, practically, we just want to treat this as nominal. So there's two levels. So we also have to ask, is this between subjects or within subjects? So between subjects is you get just one level of arousal. Within is you get both levels of arousal. So clearly in this case, it's within because each person got the high arousal and low arousal condition. It's just that for half of them, they had the low arousal first, and the other half, they had high arousal first. But everybody had exposure to low and high arousal. And the other key that's within is that they rated attraction twice. So low arousal, rate the attraction. High arousal, rate the attraction. So they rated attraction twice. And then for the other variable, which is attraction, we have, again, attraction being the interval level measurement, 1 through 10. So arousal, again, has two levels. It's within subject's design. Everybody had high and low arousal conditions. And we have another variable, attraction, which is interval. So we have a within subject's design comparing two things, high and low arousal, and correlating that with attraction. That is a paired t-test. Paired t-test comparing two levels of a variable that's nominal, that's within subject's design. So for every person, we're going to see whether they had a higher rating of attraction when they were under conditions of high arousal versus under conditions of low arousal. So this is a paired t-test. We're comparing two things, and it's within subjects design. Okay, number 4. So again, you can go through this, and you can pause the video, go through the solutions. So here we have probably my obsession with color and people's attraction. And so how are these two variables measured? So it looks like we have 3 groups. So there's some sort of manipulation. So this is an IV. And it looks like one group saw somebody in red, one group saw somebody in blue, and one group saw somebody in green. So 1/3 of the people saw red, 1/3 of the people saw blue, 1/3 people saw green. Nobody saw more than one color. So nobody saw red, green, and blue. Just one color. So here we go. So we have an IV. There's 3 levels of the IV. We have red, blue, and green. And this is a between subjects design. Everybody gets just one level of the IV. And then we are looking at that variable compared to attractiveness. Again, attractiveness is interval level measurement. So we want to compare 3 groups, 3 separate groups between subjects design on an interval level variable. This is a one-way ANOVA. One-way ANOVA, 3 or more separate groups, independent groups, comparing them on an interval level variable. And then we have, is religion related to college major? Wow, this is really simple, right? It's not a long description. So religion, we know that's nominal. College major, we know that's nominal. So how do we compare 2 nominal level variables? See if they're related. This is a chi-square. Enough said, I think. That one's really easy. That might maybe be a tell. Maybe I have to put extra words in the problem. So it's not like, oh, it's so short, it must be a chi-square. So the big thing about a chi-square is there's 2 nominal level variables. So number 6. So we have color again, but in this case, it's whether it affects people's moods. So does the color yellow make people feel happy? All the smiley faces around. So how did this researcher do the study? Each person in the study sat in a red room for 10 minutes. And then they completed a questionnaire measuring their mood from 1 to 10. And then each participant sat in a yellow room for 10 minutes and took a similar question measuring their mood. So in terms of color, we have red and we have yellow. And it looks like an IV because we're making them sit in the rooms. And so we have 2 levels of an IV. So we should ask then, what is the research design? It is within. So each person was in the red room and then they had their mood measured. And then the same people were in a yellow room and they had their mood measured. So this is a within subjects design with 2 levels. And we're going to relate that to their mood. How was mood measured? Well, it was measured 1 through 10, so it looks like it's interval or approximates interval. And so what we have here is we have 2 levels of an independent variable, 2 levels of a variable that was a within subjects design. Everybody was in red and yellow rooms. And we're comparing that variable with 2 levels within subjects design on an interval variable, the mood in this case. This is a paired t-test. T-tests, we have 2 levels of a nominal variable. We're treating this as nominal, but it's a within subject's design. And we're comparing it to an interval variable, so paired t-test. Number 7. So there's a professor that has a new way of teaching. She has 6 people in her class, and she gives the students 3 equivalent quizzes over the semester. So we have 2 variables. We have a variable here of time. So this is a little bit more tricky, but I don't mind having this in here because you need to think. So there's 3 measurements over time. So 3 measurements over time. So we're going to compare 3 things. And you could say that there's an order to it, but we don't really care because order doesn't really matter because we're not going to do any ordinal stuff practically in this class. So we are comparing 3 things. And those 3 things we're comparing is within subject's design because these 6 students took these quizzes over 3 periods of time over the semester. So for each student, we're going to compare them at time 1, time 2, time 3 in terms of their quiz scores. So we have a variable with 3 levels, and it's a within subject's design because we've repeatedly measured the dependent variable here of the math scores. That's one variable. Is the 3 times, and then the math scores, which are ratio, is the other variable. So we have 3 times within subject's design, comparing those 3 times on the math scores, which are ratio, level measurement. What is that? That is the repeated measures ANOVA. We've repeatedly measured the DV. It's ANOVA, so we have 3 or more measurements of that. So 3 levels within subject's design, comparing those 3 levels on an interval or ratio level measurement, that's a repeated measures ANOVA. Comparing 2 things, t-test, comparing 3 things, ANOVAs. Comparing 2 separate groups, we're talking about independent t-test or one-way ANOVA. If we're comparing the same people, we're talking about paired t-test or repeated measures ANOVA. Number 8, sorry about this. So relationship between median income and how many IT companies are in a city. So median income is money, so we know that's ratio. At the very least, it's fine if it's approximating interval, but it's ratio in this case. How many IT companies? So you could have 0 companies, right, in your city. So this is ratio also. So we have 2 ratio variables, and we want to see if there's a relationship between them. 2 ratio variables. This is going to be a Pearson correlation. It's also okay if you say simple linear regression because it's the same thing. And so Pearson correlation is at least approximating interval level measurement on 2 variables. It can be a ratio also, and relating those 2 variables. I think we have one final example here. So go ahead and read this, and you can pause it if you want to test yourself. So it's whether there are certain strategies that improve your memory. So using a strategy, and does it improve your memory? So this seems to be the 2 variables. So this researcher had one group of people use the strategy, and she compared this group's scores on a memory test with people who were given no strategy, a control group. So it looks like we have a manipulation of an IV here. We have strategy or no strategy. Was it between or within? this is between subjects design because there was one group that had the strategy and there was another group that didn't have the strategy. No participant had both strategy and no strategy. It's either you had a strategy or you didn't have a strategy. So there's two separate groups, two levels of a variable. This is one's an IV. It's a between subjects design. And we're comparing them on a ratio level measurement of the memory test. Okay, so two levels between subjects design, comparing two separate groups on an interval level measurement. This is going to be an independent t-test. And that's it for this video, essentially. So do follow my recommendations about what to review, and hopefully that practice was very helpful for you to prepare for the exam. So the exam is all this. There's nothing else to it. There's no calculations, etc. It's just looking at some research, identifying, I'll sort of review this here, identifying each variable and its level of measurement. And if you have some sort of manipulation, it's very useful to, not even if this doesn't even have to be a manipulation, just like that time. So if you're giving the quiz to the math students 3 times I guess it is a manipulation, but you're measuring it over time. So if you have levels, so if you have a thing that is being treated as nominal level measurement, is it between subjects or within subjects? And then I'm going to actually put this here. How many levels are there in the variable? So if there's 2 levels in the variable, this is a little bit because we have levels of measurement and we have levels of the variable. So this is, I'll put a question mark because this thing wants it. There's 2 levels. You better be doing some sort of t-test. If it's 3 levels, you better be doing some sort of ANOVA. I'm just going to put this here so if it's between subjects, design plus 2 levels, this would mean independent t-test. It's a little bit of a hassle because you have to italicize that. And if you have a within subjects design and 2 levels, that's a paired t-test. Just trying to help you out here. For 3 levels, if we have a between subjects design, and 3 or more levels, that is a one-way ANOVA. And then if we have a within subjects design, and 3 or more levels, I'm going to copy that. It's repeated measures. ANOVA. I can spell repeated measures right. So again, for these problems, you have to see what identify each variable, what's its level of measurement. If it's something that has levels, we want to ask whether it's between subjects or within subjects. So 2 levels, between subjects, independent t-test. 2 levels, within subjects, pair t-test. 3 levels, between subjects, ANOVA. 3 levels, within subjects, repeated measures, ANOVA. Then the final thing, which is we sort of went over this, but we didn't do it for everyone. So have the appropriate statistics. So correlation, I'll just go over all of them, I guess. So correlation is we have two variables that are approximating at least an interval level measurement. It can be ratio also. Looking at two variables, interval at least, that's a Pearson correlation or simple linear regression. If we have two variables, each of the variables are nominal, that's going to be a chi-square. And that should cover all of the stats that we've done. And so make sure you can do that, and then also review the SPSS labs, interpreting the output, and writing the results paragraph from the output. So I think that's it. So good luck on the final exam, and I'll be talking to you later. Come to the live sessions if you have any questions.